According to Faraday's law, first law, says that quantity of electricity is directly proportional to mass deposited during electrolysis. So that is what we have here. Quantity is directly proportional to mass of what the mass of the elements deposited. So if it's so, then it means that quantity and then is equal to mass, where K is a constant. Then K being the constant means that K is equal to quantity over mass. Then we know that quantity is also I current over what? Time. Then if you substitute for that, it means that constant is I times time over what? Mass, from this our equation here. So this is the what? This is what the first law states. And also, if we were to calculate the mass of 1 mole, that is, you know that when we talk about 1 mole now, we're looking at that's the molar mass, which means if we are to calculate that, what we need here will be, we know that it will need what? The charge which is electron. Let's use that word, electron charge, and then Faraday, and then we have the what equal to what? The K and what? Molar mass. This is the molar mass this time. Let's just use R here to differentiate it. While this other one is a small mass, this one should be the small mass, small letter M, while the capital letter M will stand for what? The molar mass, with small r representing it. So in that case, to find the constant also means that K is equal to what? The charge Faraday multiply Faraday all over what? Molar mass. This time around, remember I said we are calculating for what? 1 mole. 1 mole is equal to what? That is equal to 1 mass, molar mass of any substance. So now what it simply means, if K is equal to this and K is also equal to that, that means I times T all over M is equal to charge multiply Faraday all over molar mass. That is what we have. This equation is one of the equations that really helped me to understand how to calculate electrolysis, calculation that involve electrolysis, and that's what I'm going to help you understand this today. We're going to have to apply so many how to use them, maneuver them to get whatever you want. So if we are to calculate the number of moles or amounts, if we are to calculate amount, we can rearrange this. If we rearrange it, we will get something like this. We will have I multiply T all over what? E and F equal to small mass, that is the mass deposited, over molar mass. So remember, we have mole, that's amount, is equal to mass over what? Molar mass. And that is what we have here. That's what we have here, which means is also equal to what? N, which is for amount. That means when we are handling electrolysis, we can also use it to calculate mass directly from here by using this I multiply T all over E F, that is the Faraday, will give us what? The amount. So let me show you some other areas, some other things we can do with this. We can also generate other formulas from here. When we have this, we have, for example, we're looking for I, the current. We can also go by this mass E F over what? T, that is the time, times what? Molar mass. Molar mass. If we are looking for time, we can also go by this. That will be mass F over I m r. So just like that, by substitute each of them, we will be able to get whatever we want. But then let's just quickly go into some example questions in regards to what we have been able to achieve. We are going to be trying, said, calculate the current in amperes that will deposit 10 grams of aluminium in 4 hours. That's the first question we're going to be looking at. Now, before we go about this thing, we need to find out, in aluminium is aluminium requires 3 electrons to be deposited, which means for us to have that, that's the charge. The charge, it has the word 3. That's the first thing we need to get done here. But then we're not going to go into, we're going to go solve this problem based on a very fast method with the formula that we have already established. So what we have here to solve this problem, remember we have I times T over small mass. This is not bright. Equal to charge, and then we have molar mass. Our I is what? Current, the one we are looking for. So calculate the current. We are looking for this I. So since we are looking for the I, that is the current, we can then, what we're going to do here is times time 4 hours. Our time is 4 hours. That means we convert it in seconds because it must always be in seconds. Converting to seconds means we multiply by what? 60 times 60 times what? 4. That will give us the value in what? Seconds. All over mass, that is 10 grams of aluminium. Then we have the charge. The charge there is 3 multiplied by Faraday 96500 all over molar mass of aluminium, which is 27. So when we cross multiply this, what we arrive at will be, let's just be a bit fast. We have it will be 3 times 96500 multiplied by 10 all over 4 times 60 times 60 times what again? 27. So by this, what we'll get here, let's me put this the calculator. What we have here will be 3 times multiplied by 10 divided by so what we have, our answer is the current will be 7.45 ampere, or we can make it approximately 8 ampere. That's the answer. You can see how fast this is. Unlike the other method, this is one of the ways you can solve it very fast. Let's go to the next question that we have there. The next question is that if 20 ampere of electric current is passed through a solution of saver for 4 hours. Since everything we're doing here is for 4 hours. For 4 hours, calculate the mass of saver deposited. The mass of saver deposited is what we are going to be looking at now. So our formula remain the same, but there will be a little change. Now for silver, what we have for silver will be E to give us silver metal, which means silver needs 1 electron. Now we are looking at the mass. They will be deposited. This is what we are looking at now. So let's look at how we're going to arrange this formula. If we rearrange it, we will have I, that is the current, times time times molar mass all over charge multiplied by what? Faraday. So this is what it will look like. Now we are going to be substituting. I is for what? The current. The current is what? 20. Time is 4 hours, which means 4 times 60 times another 60, and then we have our molar mass of silver, which is 108, all over the charge, which is 1 from our ionic equation there. Then we have Faraday 96500. So let's see what we'll get in this case by multiplying 20 times 4 times 60 times 60 times 108 divided by what we have. Let me try it again. 20 times 4 times 60 times 60 times 108 divided by. So our answer here, what we have as our answer is 2.3 watts grams of what? Silver. That is what we have. That's what will be deposited. So this is one of the simplest way of solving this that will be easier. The secret of solving, getting through calculation that involve electrolysis. Now, thank you so much for being part of the class. And if you have a question, you can leave in the comment section. We'll always attend to you, because I will always go through the comments. And then remember to share and like all together.